Welcome to Brain Vision.
Hello friends, as shown in the figure, there is a double pulley having the mass 15 kg and radius of gyration about centroid is 160 millimeter, that is 0.16 meter. Cylinder A and block B are attached to the cord that are wrapped on the pulley as shown in the figure. Cylinder having the mass of 5 kg and block B having the mass of 15 kg. The coefficient of friction between the block and the surface is given 0.2 and the system is initially at rest. So initial angular velocity is 0 or velocity is also 0 when force of 200 Newton is applied on the cylinder, which is constant. Then we have to calculate first part velocity of the cylinder A as it strikes the ground. B part distance traveled by the block B before coming to rest. Let us start solving. First, we will analyze kinematics of the system. The radius of outer pulley is 250 millimeter. That is 0.25, and that of inner pulley is 150 millimeter. That is 0.15 meter. So outer pulley having the radius of 0.25 and inner one having 0.15. Velocity of A pulley will be Ra into omega c. That of V will be Rv omega c. So we can say velocity of B is Rv upon Ra. So this is the constant relation, and constant relation for distance traveled by A and B as A is equal to Ra into theta c, and that of distance traveled by B is Rv into theta c. So distance covered by B will be equal to Rv upon Ra into distance covered by A. So these are the two kinetic relations we have established. Now we will apply work energy theorem with initial and final position. So initial kinetic energy of the system is 0. Final kinetic energy half m A VA square half MV into VV square plus half IC into omega C square. Mass of cylinder A is given 5 kg, that of B is 15 kg. IC we have to calculate. So your moment of inertia of the pulley system is mass of pulley into its radius of gyration. Mass of the pulley is 15 and radius of gyration about centroid is 1.16. So it would be 0.384 kg meter square. Substituting in above equation, we will get final energy T2 half. Mass of A is 5 kg into VA square. Mass of the block V is 15 kg and velocity of block by equation 1 you may write velocity of A into RV square over RA square plus IC into IC is moment of inertia half IC into VA is omega C square, so it can be written as VA square over RA square. Now take the common factors to be outside. We can write half 5 plus 15 into RV, that is 0.15 square divided by 0.25 square plus moment of inertia of the pulley system. We have measured 0.384 VA square, that we can take common, divided by RA, that is 0.25 square. So on solving this part, you will get the final kinetic energy of the system to be 8.272 VA square. Say equation 3. Work done from 1 to 2. P into distance moved by A, force into displacement, MA into G into S, work done by friction to move the cylinder block B, minus work done by gravity on the block B. Here it is given distance covered by cylinder is 1 meter. So distance covered by block B RV upon RA into SA, 15 upon 0.25 into 1 meter. So distance covered by V you will get 0.6 meter. So if cylinder moves 1 meter downward, then block will move 0.6 meter upward. To calculate the force of friction, we have to draw the block free body diagram of the block V. Its weight will act vertically downward. There will be a normal reaction. It could be resolved into two components, mvg cos theta mvg sin of theta, and here it will be a friction. So this is free body diagram of the block V. So from here you will get normal reaction to be mvg cos theta. So force of friction we will calculate mu k into n, that is mu k mvg cos of theta. Substitute the value. Mu kinetic friction is given 0.2. Mass of the block is 15 kg. G is 9.81. Cos of 30. So on solving it, you will get force of friction to be 25.487 Newton. So work done on the system we will find P is 200 Newton into 1 meter. Mass of the cylinder is 5 kg. Distance moved is 1 meter. Work friction is 25.487. Distance moved is 0.6. Mass is 15 kg. G is 9.81. Sin of 30 into distance moved is 0.6. So on solving it, work done will be 189.613 joule. Now using work energy theorem, work done will be equal to change in kinetic energy T2 minus T1. Substituting the value from equation 3 and 4, we will get 189.613 is equal to 8.272 VA square minus 0. So from here velocity of A we will get 4.7877 meter per second. This is the answer of part A. Now when the cylinder is striking the ground, then velocity of block V will be then velocity of block V, that would be Rv upon Ra into velocity of A by equation 1. You can see so it would be 2.8726 meter per second, and angular velocity of the pulley will be Va upon Ra. So angular velocity of the pulley system you will get 19.1508 radian per second. After the cylinder striking the ground, again we have to apply work energy theorem. After cylinder A strikes the ground, applying work energy theorem, T3 will be the, we are assuming it, let T3 is kinetic energy when cylinder A striking the ground, we can find the value of T3 half mv into velocity of v ic into omega c square. Substitute the value. Mass of the block is 15 kg. Its velocity we have measured 2.8726. Moment of inertia of the pulley 0.384, and angular velocity is 19.1508. So on solving it, when the cylinder strikes the ground, then energy of the system, kinetic energy of the system is 132.305 joule. When the system comes at rest, then final kinetic energy becomes zero. So work done in the process 3 to 4 will be equal to work done due to friction minus F into distance moved by the block minus mg sine of 30 into distance moved by the block. Substitute the value. Force of friction is 25.487. Distance moved by the block before coming to rest 15 kg. 9.81 sine of 30 means half, and distance moved by the block. So work done in the process 3 to 4 will be minus 99.026 into distance moved by the block. So additional distance traveled by the block we can find. Work done 3 to 4 minus kinetic energy at position T4 minus kinetic energy at position T3. So you will get 99.026. Additional distance moved by the block T3, 0 minus 132.305. So additional distance moved by the block we will calculate. And its value would be so total distance covered by block before coming to rest has be total 1.3356 plus 0.6 meter. So final answer we will get 1.936 meter. That's all for it. Thanks for watching it.